We're gonna look at in this lecture some applications, some very interesting applications. Basically, we will look at an application problem, then set up the mathematical model for it, then solve for unknowns. Okay, so after this section, you should be able to solve some typical applications um, by using linear equations. Okay. We're also gonna study or review a concept involving proportions. All right. So first, let's get familiar with some mathematical expressions or mathematical language. So you will need to get used to it, and because mathematics has its own language to describe the mathematical operations. Okay, so first let's see 6 more than a number. So you add 6 to a number. So mathematical expression to that is x plus 6. A number increased by 3, so again you increase a number by 3. That a number is unknown and you use x to represent it. So the mathematical expression for it is x plus 3. 4 less than a number, again, a number is x, and you have a value 4 less than that x, so it should be x minus 4. A number decreased by 9, so you subtract 9 from that unknown number. Twice a number, meaning 2 times the number x. 4 times the number, of course, 4x. Again, 2x by convention means 2 times x, and 4x by convention equals to 4 times x. Okay, so 3 decreased by a number, so notice you subtract the number which is x, representing which is x from 3, so this should be 3 minus x. Okay, the difference, which means subtraction between a number and 5, or a number is x minus 5. Okay, 4 less than 3 times the number. 3 times the number is 3x, and then 4 fewer than that, so it would be subtract 4 from 3x. Okay, 10 more than twice a number, or twice a number is 2x, 10 more meaning addition. Okay, the sum of 5 times the number and 3, or the sum of, meaning you're going to add two numbers together. 5 times the number is 5x, 3 is 3, so you add those two algebraic expressions together, you get 5x plus 3. 8 times the number, which is 8x, then decrease by 7, so you subtract 7 from it. 6 more than a number, okay, just means that more, meaning you add 6 to the number x. Okay, so 5 less than a number is 20. Is just means equals to 20, right? So 5 less than number meaning that I subtract 5 from x, so you get x minus 5. Is 20 equals to 20, right? Is 12, so equals to 12. Now, twice a number decreased by 6 to x minus 6. A number decreased by 13, that's x minus 13, is equals to 6 times the number 6x. So that's why you get that. So very simple. So how we solve a word problem? Sometimes the word problem um, is difficult. Oftentimes is difficult for people because sometimes the difficulty lies in turning the problem into mathematical formulas. Okay, so typical strategies you can use are, first of all, of course, that you need to read the problem carefully. I don't know if you need to read it twice or 3 times, but until you understand it. Right? And a lot of times you want to sketch. You want to draw a sketch to help visualize the problem, and also that you want to uh, identify what is the unknown, right? Identify the unknown quantity, and of course use a letter to represent it. And then typically you want to write an equation, and then you solve the equation, right? So those are the standard procedures or outline of how to solve application problems. Okay, let's look at this example. So let's read this first. So Jenna purchased a copier for $2,300 and a 1-year maintenance protection plan. Okay, that costs $0.02, which means 2 cents per copy made. So after purchasing the copier, if Jenna makes 100 copies, then she needs to pay 2 cents per copy made. So in this case, will be 2 cents times 100, 200 cents, which is $2. Okay. Now let's suppose that she spends a total of 26 in a year, including the cost of the copier and the copies made. And we want to figure out how many copies, the number of copies she made, right? So the number of copies, in this case, we can identify that's the unknown we want to find. So we can use letter X to represent it. Okay. So what we do here. So if she made X number of copies, and per copy she will be charged by 2 cents. So I will say X times 0.02. That would give you the total amount of money she would be charged for making X copies, right? Now, plus initially she needs to pay $2,300 to purchase a copier. And the sum of those two amounts should be equal to the total amount of money she spent in that year. So this should be the equation, right? That should be the equation that you can set up, okay? And then what's left is just solve this equation. It shouldn't be difficult, right? First, you subtract 2,300 from both sides. So you would have 0.02x on the left-hand side and 26 minus 2,300. And this, of course, is just, if you do mental math here, it should be 326, okay? And then x will be 326 divided by 0.02. And you should be able to calculate it. So you do mental math or use a calculator, this should be 1,600 copies. Okay, so I'll leave you to use a calculator to verify this. So that's the solution. The number of copies she made in the past year is 163,000 number of copies. Let's look at this example here. Mark IV construction company purchased 100 acres of land. So to be split into 3 parcels of land on which to build houses. One parcel of land will be 3 times as large as each of the other 2. How many acres of land will each parcel contain, right? So what we know is this information here, one piece of land, one piece of parcel is 3 times as large as the other 2. Each of the other 2. So the rigorous word here. So if you draw a picture, it should be straightforward, right? So let's see. So one parcel is 3 times as large as each of the other 2. So roughly, you could see that. Okay. So let's see if parcel 1, parcel 2, and parcel 3, and this parcel 3 is 3 times as large as the other one, right? So And we know the total area is 100 acres. So let's see. So what we can assume is that for the other two, we can assume each is of X acres. And then the largest one would be of 3 times X, 3X acres, right? Altogether, um, this the areas of the three parcels should sum to 100. So fairly straightforward. And you combine like terms. On the left-hand side, you get 3x plus x equals to 5x equals to 100. And divide both sides by 5, you get x equals to 20, right? So that means that, here this parcel is 20 acres, this parcel is 20 acres, this parcel would be 60 60 acres. So, and let's look at this example, new example, example 3. So Javier is building a rectangular sandbox for his children. He has 34 foot or feet of wood to use for the perimeter of the sandbox. So we know that the total, basically the total length of material or wood he can use is 34 feet. Okay. What should be the dimension of the sandbox if he wants the length to be 3 feet greater than the width? Okay, so we don't know the length, we don't know the width. So, but let's just first illustrate this toy rectangular box. Okay, we know that the perimeter, the longest perimeter that he can build is 34 feet. So that's your constraint. Okay. So we know the length of this sandbox will be 3 feet longer or greater than the width. So we can assume the width is x, then the length would be 3 foot or feet greater, so it would be x plus 3, right? And then now it becomes easy that because we know the total perimeter, which equals to the sum of the lengths of all the four sides, right, is 34. So which means that because this is a rectangular box, so we know that on this side its length is x, and on this side its length is x plus 3. So therefore, if we sum it up, we would get 2 times x plus 3, that's the same as x plus 3 plus x plus 3, plus 2 times x, the sum of the length of the shorter side, and altogether this should sum to 34. And then we just solve it. So we get 2x plus 3, or if distribute 2 times x is 2x, 2 times 3 is 6, and then we put 2x equals to 34. Now you can combine like terms. 2x plus 2x is 4x plus 6 equals to 34, and you subtract 6 from both sides, you get 34 minus 6 equals to 28. And divide both sides by 4, you get x equal to 7. Right? So x equals 7 meaning the width is 7. So x equals to 7, and then x plus 3 obviously equal to 10. So that would be your solution. So the sandbox needs to have width equal to 7 feet and length equal to 10 feet. What about this example? Kim is selling her homemade jewelry at a craft show. Determine the cost of a necklace before tax if the total cost of a necklace, including an 8% sales tax, is 34.56. Okay, so again, let's figure out what it's talking about here. So we know the total cost, including the tax, is 34.56, right? And there is an 8% tax included, and what we don't know is cost before tax. Cost before tax. So we can use let X be the cost of the necklace before tax, right? So that's X. Now we need to add the tax on. So the tax 8%, which means just 8% times X, right? So that will be the total cost, the pre-tax cost plus tax, and this equals to 34.56. Okay, now 8% again. We talked about this in the previous class. If we convert it to decimal, it would be 0.08. So x plus 0.08, 8% equals to 34.56. Now this combined like terms, you get 1.08x equal to 34.56. So x equals to 34.56 divided by 1.08. Again, I will resort to my calculator, which is not our concern here. Why not using the technology, right? So 34.56 divided by 1.08. That gives me 32. Okay, so the pre-tax or before tax cost is $32, and after ending an 8% tax, the total cost is 34.56. So with ratio, so what is the ratio? Ratio is just quotient on two quantities. For example, 2/3 and 1/4. That's a ratio. Okay. Sometimes then people write 2/3 right as 2:3. So that's ratio of two quantities. That probably illustrates that much more clearer. So one quarter you can write that at 1:4. Okay. Proportion. The book says it's a statement of equality between two ratios. I'm not quite sure, if this definition makes sense or not, but you're going to talk about, overall, you're going to talk about the ratio of two, um, the equality of two ratios. So something like that, okay? So let's look at an example here. By the way, that when we talk about proportion, oftentimes we need to use calculation called cross multiplication here. So example, if you have two ratios are equal, A to B equal to A divided by B equal to C divided by D, then so you do cross multiplication. So this is what I mean. A times D equal to B times C. Okay, so AD equal to BC. Well, you don't want to B equal to 0, you don't want to D equal to 0 because they are the denominators. So that's cross multiplication. Okay. For example, let me give you a quick example here. So suppose 1/2 equal to x over 3, then we would have 1 multiplied to 3 equal to 2 times x. Okay, or this is the same as 2x equal to 1 times 3, which is 3, right? So 2x equal to 3. So x equal to 3/2 in this case. So that would be your solution when you set up the proportions or set up the equality of two ratios. Okay. Just like this example here. Insulin comes in vials labeled with the number of insulin units per cubic centimeter, cc cubic centimeter of fluid. An insulin vial labeled U40, meaning it has 40 insulin units per cc, okay, of fluid. Tyler's insulin dosage is 30 insulin units. how many cubic centimeters are needed for Tyler's dosage. Okay, so all we need is set up the quantity of two ratios because the insulin vial have to be made by the same proportion. Okay, so by the way, that this type of things are required of becoming a qualified nurses. In fact, that before you can become a uh, practice nurse, you will have to take similar tests like this type of questions. Okay, so let's see the 40 U40 insulin vial. Okay, means 40 insulin units per cc, right? So per cc, let's see, of fluid, so 40 insulin units, right? Now you have a 30 U30. So this is your U30. So you know there are 30 units of insulin in the solution in the fluid, but you want to ask how many cc unit you need. Notice the two solutions must have the same proportion of insulin. So therefore you can equate that. And then obviously if you use cross multiplication, you get 40x equal to 30 times 1, which gives you x equals 30 divided by 40, which is 0.75, and here the unit is cc. So that's your solution. So that's it.